Right, so I'm going to go to my demos folder, make a folder for this exercise I'm going to do. Actually, I'm going to go to my exercises folder, and then make a folder for this exercise we're about to do. I'm going to do this in JavaScript, so I'll make a little main.js file, and then we'll open it in VS Code. Right, so for those of you who don't remember, I'm writing a function that's going to take in an array of integers and a target number. And I'm going to try to write a function that will determine if there is some pair of integers in the array that sums up to the target number that was passed in. So there's my function. I'm going to test this out with an array. And then the number 9. So if this function works correctly, it should be able to loop through this array and find that 4 and 5 can be added up to produce 9. So I'm expecting this to return output of an array with 4 and 5 in it. So that's what I want to get. That's what I'm expecting. Does anyone have any thoughts on how I might start this problem? What's an approach I could use?
Use a loop to compare each number.
Okay, so I'm going to use a loop.
You could probably use a nested for loop. So you can grab the first value, then the second value, go through the first iteration. It's going to grab the same value twice. So you can make sure that to that first loop, you can do an if check. So that way, if the first number and the second number are the same, that you can skip it or something like that.
Yep. So I'm going to do a for loop over my array. And then we're talking about doing a nested loop because I need to compare every number against every other number. So I'm going to just do another for loop inside of my for loop. And do a different variable though this time.
And I think when I was doing it, I used the I think a for, is it I can't remember. I think it's for of or in loop that grabs the index and then just grabbing the index as the value. I don't know if which one performs better, or if you have like any suggestion, if there's any ups or downs or positive or negatives between just doing it this way where you just set an index and do a loop this way versus like a in or of for loop.
So you can use a for of loop to loop over arrays. Actually, that might not be perfect in this situation because I need to know what I is. We'll see that in a second.
Got it.
But so anyways, for of is a kind of newer construct in JavaScript that lets you loop over arrays in a pretty similar way to how it looks in Python. So instead of, this classic for loop syntax, you can just say like for let variable of array and then just loop over it. For in is similar, but that's for objects, not arrays. All right, so let me just make sure that this code works so far. I'm just gonna console.log the numbers that I've got here. So I don't want to console log I and K because that's just counting up through the length of the array. I want to see the actual numbers in the array. So when we look at input array at I and input array at K, just want to see what these are. Cool. So while I is 1, K counts up to 5. When I is 2, K restarts, counts back up to 5 again. Then we set I to 3, K restarts at 1, counts back up to 5 again. So this looks like what I was expecting from my nested for loop. I'm doing a for loop inside of my for loop. So now what I want to know is for each of those combinations, do they add up to 9? So, I'm just looking through here with my eyes, and yeah, down at the bottom here, it looks like we did print out this pair. So I just need to add some logic that actually checks and confirms in code that that's correct. So we'll say if all right, so if I can add up the value of the array at I and K, and if that's equal to the target, then I've found the solution to the problem, because that's all it's asking me for. Just some pair of numbers in the array that adds up to the target. So I'm going to return a new array then. That's just input array I as the first item and input array K as the second item. I'll take a look at that. Take out that console log and only console log the final result here. Cool. So that gave me roughly what I was expecting. An array with just 4 and 5, which add up to 9. So there's still one problem with this algorithm. I think someone already mentioned it, but if you want to just repeat it, or anyone else, Bao?
So if you are going through, like if your number is a even number, does that gonna use the same number twice since you didn't clarify the different index are not the same? So if it's 6, you're gonna use 3 twice?
Yeah, so one of the requirements of this problem was that it needs to grab a pair of numbers that adds up to the target. But the way I've written my logic currently, it's possible that both I and K could be the same number, could be the same element of the array. And then that would produce an answer that isn't actually solving the problem. So to demonstrate that, let's try. Two. So if I run this sum pairs with that same array trying to get a target of 2, this algorithm, the way it's currently written, is going to say like, oh, 1 and 1, we can add those together, and that gets us 2. Because I and K are both going to start at 0, and they're both going to be on 1. And so that's what it tells me. But I know that that's not actually a correct solution for this problem. So I need to update my logic here so that this isn't sufficient, just that they equal the target, but also they must be different from each other. So I can just add an and here. All right, so if I can get through the whole for loop without finding a solution, I'm going to print out no pair, or I'm going to return no pairs. Okay, so now my function actually behaves correctly, because even though it's able to, get 1 and 1 and sum those up to 2, because of this extra logic I added, my program is no longer going to accept that as a solution, because that only works when I and k are equal. So I need to actually get a pair of numbers. They have to be 2 different numbers. Porphy, you have your hand up?
Yes, thank you. Could you also alternately just, for the for loop, make k equal I plus 1?
No, because that would just put k always 1 ahead of I. They need to loop through like kind of independently. Like k does a full loop before I changes out. Maybe I'm not understanding your question. Could you say it again?
No, so if k is I plus 1, it'll start with I and add I to everything except for itself. And then it'll move on to the next number and add it plus everything except for itself. But you wouldn't need to re-loop back past that first one because you already did it when you did the original I.
Or do you mean if I just started off my for loop like this? Like I is 0, k is 1?
Yeah, you can start at, I would do k is I plus 1 just to make it, even if somehow they wanted to start somewhere else.
Mhm.
But yeah, even if starting just at k being 1 higher.
So that prevents them from both using the first item as like a 1 item pair, but that doesn't stop them from like, if the target was 4, then on the second iteration, they would both be on 2, and that would still sum up. So I think I still would need to have this logic here.
I think if you said k equals to 1, it won't. I don't think that works, but I think he's saying if you said k equals to I plus 1.
Yeah, theoretically, it would create a shrinking array. I think Porphy's correct.
Oh, because we're doing it in the loop.
Right.
'Cause it would shrink your second iterations down. It would skip over iterations that were already matched.
Yeah,
I think.
that's my thought process too.
So this is an example where we would recommend you use the debugger so we can see what's happening when we change things.
So let's see, I'm going to do this Porphy's for loop here. Let k equals I plus 1. Just going to console log I and k in the inside. See what that looks like. So yeah, the inner for loop gets smaller and smaller because it's not repeating the earlier parts of the array every time. That's an interesting idea. I haven't thought about this. Usually I don't do anything too complicated with the for loop initializer. It's just some specific starting point, usually at the beginning of an array. Stuff like this is a little bit hard for me to think about. So I'm going to show you what I think is a little bit a better solution, something that's easier to reason about. But it's cool that we're thinking about this, all the different ways we can, manipulate our code, make our for loops work how we want. Got some more hands up. Jake?
Oh yeah, I was just gonna say, it seems like some of the questions we're dealing with here are trying to make this more efficient in some way.
Mm-hmm.
And the reason I hate like nested for loops like that is because it usually hits all those different things like twice. I don't know, I didn't do the JavaScript one, but I did the Python one, and I know Python has a really nice option method called pop which pops the first item off, and it also makes the list that one item shorter. So it removes it from the list. So you pop the one item and then you just look at that against every other item. And then you could just forget about that. And then you pop the next item again, it keeps making the list shorter. So I didn't know if JavaScript had like nice list functions like that. I know Python has a really good way of dealing with lists, but I'm not too experienced with JavaScript yet. So I didn't know if that's like an option to like pop the first item off and it gives you a separate list that like destroys the list in a way, makes it slightly smaller.
You could do that in JavaScript also. There's a pop method in JavaScript that works similarly to the one in Python, removes the last item from the list. But while that would improve the performance of this algorithm, it doesn't improve it enough. Like currently this algorithm has terrible performance, and the improvements you're suggesting make it better, but still not acceptable for most circumstances. So I'll show you what I think is a little bit better. But first, I just want to demonstrate why this is so awful. So, people have mentioned already we're doing a nested loop. Since there's a loop inside of a loop, every time the array gets one larger, we're increasing the number of iterations we have to do, and then also the number of iterations we do per iteration. So it just gets squared. So let's imagine we're trying to solve this on a much larger array. So instead, this is our target array, mostly 9s, but 2 1s at the end. And so our target number is going to be 2. So you should be able to look at this array and kind of guess what the solution is going to be. We're going to have to loop through every single one of these 9s here until we can find the last 2 1s, and then we'll know that those sum up to 2. And you watch it there, it took a few seconds, which isn't too long, not as bad as yesterday, but it's still not like the blink of an eye because we have to do this nested loop over a pretty big array. But honestly, this isn't even that big. Like it all fits on my screen. More commonly, a big array might have thousands or millions of items in it. So you can imagine if just this took like 3 seconds, just add a few more in there. This algorithm would definitely just be way too slow for a serious amount of data that you might encounter in your actual job. So let me show you what I think is a better solution. All right, so oftentimes when you're solving these kinds of algorithmic problems, you'll be given an array, often an array of numbers, and you have to find something in the array, operate on it in some form. And oftentimes the problem becomes much simpler if you sort the array first. When you're just looking at like an array of random digits, you might have no idea just how you're supposed to solve the problem. But once you sort the array and then look at it like that, it becomes much more obvious what a good solution could be. So I'm going to start out by sorting this array. This is a little shortcut sorting function here, should sort these numbers numerically. I just want to make sure I did this correctly. Console.log input array. But let's use an array that's not actually sorted to begin with. And we'll have a target of 13. So we should be trying to find 8 and 5 to make this work. Wait, I have to actually call my new function. The better sum pairs. Okay, so it looks like I've sorted the array. So this should be a little bit easier for me to work with. So I'm going to have to do something a little bit tricky here. Before I was doing, that nested for loop, and I don't want to do that. I want to find some way to loop through this and compare every number, every combination of two numbers, but only loop through it once. And so here's the trick to this. Instead of doing two loops with a for loop inside of a for loop, I'm going to do, it's kind of like one loop with two different pointers. We're going to do two loops kind of simultaneously in two different directions. So imagine if instead of looking at one number at a time, we're looking at two numbers at a time. So just look at 1 and 14 and then add those up together. If that number, if the sum of 1 and 14 is too small, it's smaller than our target, then we move this bottom number up 1. Then we compare 3 and 14. If that's too small, we move this up 1. If that's too small, we move that up 1. And if that's too small, then we know a solution does not exist in this array. And then on the flip side, if the sum of 1 and 14 is too large, it's bigger than our target, then we just take the top number and move it down. So then instead we compare 1 and 8. If that's still too large, then we compare 1 and 5. If that's still too large, we compare 1 to 3. And if that's still too large, then we know a solution does not exist in this array. So we're being a little bit smarter about it because we've sorted it first. And we're being sensitive to whether our sum that we come up with is too big or too small, so we can adjust intelligently. And we're not just guessing and checking every possible combination. So to see what that looks like after I've sorted the array, so I'm going to need to keep track of the start and end of the array. So we'll say let start equals 0, let end equals input array dot length -1, because arrays are 0 indexed. And then I'm going to be looping. It's not going to be a regular for loop because I'm not just going from the beginning to the end, but it's kind of this like wacky custom loop where I'm going to go from the start and end in towards the middle, sort of. But I know that the start should always be before the end, because if those cross over, then it means I'm checking the same number, and then that means there's no solution in the array. So I'm going to just verify that start is less than end. So then I want to compare the sum of the items in those array indices. So let's check if input array at start plus input array at end, if that sum is equal to the target, then great, I have found my solution. Okay, but more likely, I'm not going to get it on the first try. So we'll say else if so if that's greater than the target, that means that the top number is too high. We need to move the top number down to make this smaller. So I'm just going to say and minus minus. And then the last case, if the sum of those two values is less than the target, then the number on the left is too small. We have to move that to the right to make it bigger. So that's going to be start plus plus. So this should get 8 and 5, summing to 13. Yeah, so I got exactly what I was expecting.
Hey, Raphael, I think for this challenge, it is possible to have more than one answer. So I think we might need to. So not for your example, but you could have more than one combination that sums up to a target, right?
I'm just finding the first combination and returning early.
Right, but if we had multiple combinations, I think per the requirements, you can return multiple sets.
Yeah, it does say that. So yeah, we could take this one step further by finding multiple different pairs that satisfy the requirements instead of just stopping at the first one. I think I'm gonna leave that as an exercise to the reader though. This might be a good time to take a break. Actually, does anyone have any questions about the solution first? Before we take a break?
Would you mind going over the sort method? I understand how, like, I don't understand how it works. I understand what it does, but just if you could give some clarification on that.
Yeah, I would actually love to go over the sort method. And so when we come back from the break, I'm gonna do a little mini lesson on that.
Awesome, thank you.
Any other questions?
I had a question in chat if you read it over.
I did not. It's not easy for me to see the chat while I'm sharing my screen.
Okay, yeah, it was basically for your time complexities you were trying to solve. You were using a sort to start with, which is n log n for its complexity. When we were using the logic on the first example, where you're popping off the values or using what Porfirio said, or I can't pronounce his name, had said it's the same complexity. So this code's a lot harder to understand, read, and follow compared to the first, in my opinion. I was just trying to see what your opinion for that would be.
You're right that this code is certainly much harder to follow, but sometimes that is the price we pay for having efficient algorithms.
Well, I was saying that it's not more efficient. If you're using a sort, if it comes in sorted, it would be, but when you implement this sort, it's not any more efficient.
I mean, sorting is much more efficient than like an n squared algorithm. So as long as sorting the array is more efficient than what you were planning to do otherwise, it can give you some improvements.
Well, so the JavaScript sorts n log n, and doing a pop like we're doing in the previous example that we were trying to do. In the previous example, it's also n log n.
You sure about
You go
that?
over once, and yes, because you go over the entire array once, and then less than once as you're moving the items, as you compare the items.
I might have to look into that.
That's it. Put everyone on break. We can table that for later.
Sure. I'll say this is maybe a more famous algorithm, one that I've seen before, and there are other problems that you'll solve in similar kind of ways to this, which is why I chose to show this to you, just this idea of doing a loop with 2 pointers. But yeah, I'd be curious to explore that other solution a little bit more in depth. But yeah, so let's take a break now, come back at 11:10, and I'm going to show you how to sort stuff in JavaScript. All right, so let's say we've got an array of numbers. Great, so those are all numbers. So let's just see what happens when I try to sort these with no arguments or anything. Just oh my gosh. Console.log. Numbers.sort. So does anyone have any expectations already about what we're going to get when we sort this array? Just no arguments.
Default should be from low to high when you're talking about integers. Yeah.
It'll be alphabetical, right?
It should be low to high, but this is JavaScript and not everything is as it should be. So yeah, the actual default sort order for the sort function is alphabetical. So it's going to sort these numbers alphabetically, which means that 12 comes before 5 because it starts with a 1. So yeah, 1, 1, 12, 22, 3, 3, 4, 5, 6, 65, 99. That is not numerical sort. That's an alphabetical sort. So my point here is that you don't really need to worry about the default sort behavior for the sort function because it's useless. If you want to get any value out of the sort function in JavaScript, you need to know how to define a custom comparison function. Now, depending on the specific problem you're going to solve, there might be little like shortcuts, like smaller comparison functions you can use that efficiently do what you need to. And I realize that maybe it's hard to learn how the sort function works because a lot of documentation online is just showing you these little shortcuts without really explaining the whole thing in depth. So I want to show you how a proper full sorting comparison function works so you can sort any array based on any criteria. So this is useless. Bob?
Sorry, Rafael, I just have a quick question. That's a basic question.
Mhm.
When you mean alphabetically sort, is this like the first letter of each word of those numbers? Or
Right, like imagine that 12 is not the number 12, but it's a word composed of the number 1 and the number 2. And so when you alphabetize, you look at the first letter first. And so 1 comes before 9 or any of these other numbers. So 12 would go before anything else except for 1.
okay. Oh, thank you.
Don't worry about it too hard. It's not useful. I'm going to show you the good stuff now.
Okay, sorry.
You're good. So an actual proper sorting function. Let me write this a little differently. Okay. So in order to tell JavaScript how we want our functions sorted, how we want our arrays sorted, we have to pass a function in to sort. So we've got a function here. Now this function is going to be called with all of the elements of the numbers array 2 at a time. So I'm not looking at the whole array at once and trying to sort it. That's mind-boggling. I can't think like that. We're just looking at 2 items at a time, and we have to determine if the first one goes in front, if it goes behind, or if a third thing. So we have A and B. Let's just not actually sort them yet. I'm just going to console log these, see what that looks like. Take that out. So this is my callback running for my sort function. It's just trying to compare every possible combination of 2 items in that array. First, it's going to compare 5 and 3, then it compares 1 and 5, 99 and 1, 4 and 99, just all the different combinations of 2 numbers from this array. And then my responsibility as the programmer here is to write any custom logic I want that will tell JavaScript how I want them ordered. So there are 3 specific situations. I'll say, so either you want A to be in front of B, you want B to be in front of A, or you don't care. So that's actually 3 separate situations. So at a minimum, a proper sorting function should have at least 3 return statements. So we'll say if A is greater than B. So if A is greater than B, and I want to sort this numerically, I'm going to indicate that A goes in front by returning 1. Could be any positive number, but I'm just choosing 1 for simplicity. So else, if A is less than B, what am I doing here? If A is less than B, we return -1. So in a sort function, you can return any negative number to indicate that B goes before A. Just the opposite of returning a positive number. Okay, and then the third situation is where we're indifferent about the sort order. So let's say our sorting function is comparing the number 4 against the number 4. I don't care which of those 4s gets sorted first in the array. I'm completely indifferent between them. I literally can't tell the difference. So we'll say else if A is equal to B, we return 0. Just gonna capitalize these, make it a little bit easier to read. Okay, so now let's see what our sorted array looks like. Okay, so that is actually sorted numerically. So if I wanted to flip it around the other way, all I have to do is flip these signs. So I return -1 where I was previously returning 1 and vice versa. So now it's just sorted the other way just by flipping that sign. If I want, I can even make this dynamic. So you've probably seen like in lots of dashboards, you'll be like looking at a table and it's just sorting all of your information, a bunch of different columns. And you can click any of the column headings to sort it by that column, and you can click it again to reverse the sort. So it's nice having a really simple way to reverse a sort. I'm gonna put a little variable here. Let sort direction equals 1. Turn negative sort direction. And the other case, we return sort direction. So now the sorting algorithm works exactly the same way, sorting descending 99 down to 1. But now if I want to flip that sort, I can just change this variable. I don't actually have to change the function itself. So you can imagine just, someone clicks on the column heading and you change the -1 into a 1 or vice versa. You just multiply by -1. And so now that flips my sort order. We're going ascending from 1 up to 99. There was a hand up just a moment ago. Andrew?
Yeah, I had a question. If some of the numbers are strings, does JavaScript do the type conversion automatically?
You're saying in our input here, some of these are strings?
Yep, because I've seen it like in problems where we have like the numbers as strings. Will JavaScript like type convert over to int immediately, since like JavaScript's supposed to be like that smart language thing?
There are cases where it does do that. One of the challenges yesterday, I basically ended up running a map over an array of string numbers, and then it let me run the map and do a math operation and then converted all of them to numbers at the end.
So I just made some of these numbers into strings. Now I'm running the sort function again, and it seems to still sort the strings as if they were numbers, which is honestly kind of upsetting to me, but that's how JavaScript works. So the moral of the story here is you should probably not even be trying to sort arrays that have dissimilar items. Ideally, they should be all the same kind of thing in order for them to be sortable. I would just question your intentions here, but yeah, that was interesting. JavaScript has a lot of weird parts. Brendan, you have your hand up?
Yes, a question on the sorting method that you just did. When you're putting in that, if A is greater than B, return -1 or 1, is that assigning the value of 1 to that particular number and then saying is 1 equal to 1 and moving them? Or exactly how is that working?
When I'm returning -1 or returning 1,
yes,
that's just to indicate the relative ordering of A and B. Because every time this function is called, it's going to be looking at 2 items from the array. And so you just return a positive number to say the first item goes first, or return a negative number to say that the first item goes second. It doesn't actually matter what number you return. It doesn't like get saved anywhere else. Just if it's a positive number, that's A before B, a negative number is B before A. Does that help? Do we have other questions? I think I saw some hands up. Jake?
Yeah, I was just wondering if you put in that numbers array, if you put like the word apple or something, what would that do to the sort? Does that?
Oh, God. Let's find out. I guess the strings go at the end. Except empty string goes at the beginning. I don't know.
What if
There's-
you oh sorry, go
I
ahead.
think it might be counting the string.
Maybe. I have no idea what JavaScript is doing, but you should not rely on the like kind of wacky undefined behaviors when it just automatically converts things together. This is why I try to emphasize being clear about what types your values are, because when you try to have JavaScript do things with different types of things, it gets a little crazy. Justice?
So I was wondering if you set like the 3 and the 3 or the 1 and the 1, if you set 1 equal to a string, set 1 as a string, would that break it?
I'm sorry, do you mean here?
No, so in the array, I'm sorry. So there's like, so 1 and 1, 3 and 3, they're both, in the array twice. So if you set 1 as a string and then 1 as an integer, did that break it?
Seems like the letter 1 gets sorted next to the number 1. So somehow sort is interpreting them as similar. Again, I wouldn't worry about that too much. Don't rely on it. You should tell your program exactly what you want it to be doing instead of relying on like weird automatic behaviors. Porphy, do you have your hand up?
Yes, thank you. So could you go back to the code real quick, please? So I'm trying to figure out what sort is doing exactly to give this A and B value, and why returning that to sort tells, I guess, the algorithm inside of the sort method where to put that number. Like, it seems like it's overriding its regular logic that it has already built into it. I'm just not understanding how and why.
Yeah, so passing this function in here into sort, this overrides the default logic for sort, and we're telling it exactly how we want to sort. But so I never call this function myself. I've defined it. I'm never actually calling it. I just pass it into sort. So JavaScript calls this function for me. It calls it as many times as it needs to in order to get this array perfectly sorted in a sensible order, based on my criteria in this function. I don't know if this helps, but yeah, so that still works the same way. So here all I did is I defined my sorting function just as its own standalone function. I assigned it to a variable name instead of using an anonymous function, and then I'm passing that function in. So I've got a function here that tells sort how to sort. And you'll note I am never calling sort algo. You don't see this with the parentheses anywhere in my program. I'm not calling it myself. JavaScript in the sort method is calling my comparison function as many times as it needs to, comparing all the different possible combinations of 2 items in this array until it knows what order everything goes in.
So is what's happening inside of sort that it's taking, like, normally, right? Like if you hadn't put this function in there, it would just compare A and B, A and B, and B going all the way down the array and either move their index +1 or -1 or keep it the same. And then you're just overriding that and saying if it's greater or lesser than, like as an integer, just keep move the index down 1 or move it up 1. Is that, I'm just trying to figure out what it's actually doing in the background.
Pretty much that, yeah. Depending on, whether I return positive or negative, it'll rearrange the items in the array. So I think you got it. There's definitely a little bit of magic happening under the scenes. Jesse, do you have a question?
Yeah, just more of a quick question dealing with comparisons dealing with JavaScript and Python on the sort function. What is the main difference that you see? Because I always trying to compare the two.
Just asking me to compare sorting in JavaScript versus Python. So I guess here's how I'd put it. If you don't want to write a custom sorting function like this, then the sort method in Python is much more useful. because the sort method in Python has a few like options you can pass it. You can make it be a little bit smarter automatically. It can sort dictionaries based on a specific key, or it can sort lists of dictionaries, I think, based on a specific key. Whereas in JavaScript, you'd have to write a custom sort function to do that. In JavaScript, the default sort behavior is totally useless until you write one of these custom sort functions. But that being said, there are lots of like real life scenarios that are still going to be more complicated than what Python provides you for free easily. And you're still going to have to write a custom sort function to describe exactly how you want things arranged. Because a lot of times in real life work scenarios, you're not solving some beautiful mathematical puzzle. There isn't like a very good logical reason why everything is sorted in the way it is. It's just like your boss comes in and he's like, yeah, United States goes on the top of the country list because that's where all of our customers are. I know it's not alphabetical, but that's where it goes. Stuff like that.
Thank you. That helps.
Do you have any other questions about this? All right. So with the time remaining we have this morning, I'm going to give you all a really quick in-class challenge because I know you like having a little in-class coding mixed in with your lectures. So I'm going to show you an array here, an array of objects. Say it's an array. Bob is a carpenter. Carol is a neurosurgeon. Dan is a boxer. And then we have Eve, who has no job. So your task, we'll make this a two-part problem. Step 1, sort the array alphabetically by job. So in theory then, if you sort it alphabetically by job, you should get Eve at the start, because an empty string is, comes alphabetically before any other letters. And we should get Dan the boxer, Bob the carpenter, Alice the journalist, and then Carol the neurosurgeon. So that's sorting this alphabetically. So here's the problem, is that generally when users sort a list of things, they are not expecting to see blank data. So if I sort this whole list alphabetically by job, I'm trying to search these people by their job. And if it shows me first people that don't have a job, like that's technically correct in a certain sense, but it's also not what I wanted. So this is actually a pretty common use case. This is something I've been asked to do a lot as a developer, especially as a front-end developer, just sorting lists, but making sure that null values are always at the bottom. The things that people don't expect to see sorted at the top are actually at the bottom. So step 2, sort the array alphabetically by job title, except put empty jobs at the bottom. So anyone whose job is an empty string, like Eve, they should be sorted at the bottom. And yeah, that's the challenge. Work with this array, writing a custom sort function that might look a little bit like this, but it'll be different because you're sorting words alphabetically instead of numbers. Question? Jesse? I think you're on mute.
I forgot to put my hand down, sorry.
No worries. Grant?
Would you mind pasting this whole thing, including the sort example in the
Sure, why not?
Slack? Thanks.
All right, so let's take maybe 10 or 15 minutes to work on this. I'm gonna check in at 11:45 and we'll see how far we get. It's very possible that we might not be able to finish it or figure it out, but I don't just want you to think about this and struggle through it before I show you a solution. All right, class. It's a little after 11:45 actually. So I know I can still see some puzzled faces on y'all, so I suspect many of you are still working towards a solution, but I don't want to cut into your lunch. So I think this will be a good time for me to just show you how I would go about this. So for starters, I'm just gonna copy this algorithm here. Because the next one I write is going to be pretty similar. So I'm going to call this sort jobs. All right, we're going to call this sort by job. So let's just see what this does so far. It's definitely not going to work, but I just like to see what the current behavior is, so I know, what the next thing is I need to fix. That definitely returns nothing. Oh, right, need to actually log something. So I'll log sorted people. All right, so that doesn't seem like it did anything, which is roughly what I was expecting. Because now A and B are objects. They're not strings or integers, so I can't directly compare them with just greater than or less than. So I just look at that real quick. Yeah, show me A and B, these are each objects. I can't just do a greater than or less than comparison with that. So I'm going to have to index into them, access the properties. The thing that I actually want to compare is the job property. So looking at this output again, everyone has a job property. Each of these objects has a name and a job. So we're going to compare if A.job is greater than B.job. So note that the greater than operator can compare things alphabetically as well as numerically. If you use this to compare two strings, it'll tell you which one is alphabetically like first in the alphabet, which one would come first in a dictionary, for example. And same thing here, A.job less than B.job. And if two people have the same job, then we don't care which one gets sorted above the other one. So now let's see what that does. Okay, so this is getting a little bit closer. We've got boxier, carpenter, journalist, neurosurgeon. So that's all in order, except Eve is at the top, which, like I said before, is technically correct, but it's not what we want. So I want to add some exceptions to my sorting function to make it work exactly the way I need it to. And this isn't going to be super pretty. I'm not solving some like ancient mathematical puzzle that has a really elegant solution to it. I'm just going to add some more if statements here to cover the extra cases that I need covered. So what I'm concerned about here is if A.job equals empty string, and B.job is not empty string, then we return -1. B should go before A because person B has a job, person A does not have a job, and then we always want the empty string jobs to go to the end. If they both had no job, it was two empty strings, then we would be indifferent. So that's why we have to have both of these checks, that one of them has a job and the other one does not. And then similarly, if A.job is not empty string and B.job is empty string, we'll do the opposite. We'll return 1. I'm gonna make all these else ifs. Even though they all have return statements, so there's no way for multiple of these to run in one execution of the function, but this looks a little neater to me. So now I'll
Will we
run,
refactor some of this with ternary statements?
pardon?
Could we refactor this with ternary statements?
I don't think a ternary would be a good choice in this situation.
Okay.
Or, I mean, you could use it, but I would recommend against it. Ternaries are good for very simple situations where it's just an if statement and an else clause, and then you want to assign something to a variable based on that, maybe. But for anything more complex than that, I would prefer to use a bunch of if and else if statements because I think they're easier to read.
Thanks for feedback.
So it looks like Eve is still at the top, so I might have gotten my symbols flipped around. So when a.job is empty string, maybe this is supposed to be positive, and this is supposed to be negative. There's only two options, so just do it the other way. Okay, there we go. So now I've got them sorted by job alphabetically, boxer, carpenter, journalist, neurosurgeon. And then Eve is at the bottom because I've hard coded in this exception for people whose job is an empty string. So that's in a nutshell how you can sort anything in JavaScript. This is not outrageously complicated, but it's pretty tricky, and I want to make sure that you know this well. I want to say that I've had a handful of different jobs, both front end and back end, and we tell you that the interview is always harder than the actual job. I've had some actual jobs where like this is the hardest thing I did. So if you can do that, then you're probably ready to be a junior developer somewhere. In fact, for my first ever web development position, like 8-9 years ago or whatever, my interview, I was asked to do some algorithm, I had to sort something, and I whiteboarded a sorting function, kind of like this one. And I was offered the job that same day when I got home before I'd even taken my shoes off. They were like, this is the guy we want. No junior developers know how to do sorting functions just off the top of their head, but this guy does. And so that made the difference. They hired me. But yeah, beyond just impressing people in interviews, this is important. Like most of the work you do as a junior developer is just sorting lists of things to display to users. Do we have some questions, Grant?
Sorry, forgot to put it down.
No worries. Bao?
Just a quick question. I think I probably missed something. So in the first two if statement, why did you use return 1 instead of return the sort direction?
That's actually a very good question. Because people with empty string jobs should be at the bottom of the list no matter what the sort direction is. So like look at the output here. If someone asks for a descending sort, forward to the alphabet, box carbon journalist neurosurgeon, that makes sense. If somebody wants the reverse sort, do sort direction is 1. So they want a reverse alphabetical order, neurosurgeon, journalist, carpenter, boxer, but Eve still goes at the bottom. No matter what the sort direction is, if someone is missing data for the thing that you're sorting on, you should expect that to be at the bottom.
So oh, sorry.
So yeah, that's why here I'm just hard coding in 1 and -1 instead of relying on the sort direction, because I put empty strings at the bottom regardless of the user's selected sort direction.
So is that 1 -1 just stands for the index of the or the position within that list?
Think of it more as forwards or backwards, I guess. Positive number means this thing goes in front. Negative number means it goes behind.
Okay, so it's more like a direction.
Yes.
Okay.
And then 0 being no direction, or we don't care what direction.
Okay, but you could still use the sort direction as a first one and the negative sort direction as a second one.
I mean, depending on the requirements, it would behave differently. So if we did that. So now we have the reverse alphabetical sort with Eve on top. We flip the sort. Now Eve is on the bottom. So by using the sort direction variable as part of that check, that means that like we might potentially sort empty data onto the top of the list. So if that's what you want, then yeah, you could use that same variable throughout. So you get that consistent behavior. But I think it's a reasonably common use case for a business that there's some particular value that should never be on the top of the list.
Okay,
so yeah, and this is how I do that. Are there other questions?
Yeah, so instead of the first two comparison statements returning 1, -1, if you want it on the bottom, wouldn't it be better just to test the A dot job and return infinity or negative infinity if you want it on top or bottom?
Sorry, I'm not quite sure if I follow. You're asking, what are you suggesting I would do? Put these on the bottom and then. John?
Oh, I'm still muted. I
Yeah.
replied in the thread for the first two lines, 43, 44, if you replace it with what I pasted in for the response.
I'm sorry, where did you paste that? Or where did you, is that in the Zoom chat you said?
You're muted again, John.
Damn it. In the Slack chat where you had posted up this exercise, I did a reply to it.
Oh, I see.
And using that in place of those two, 43 and 44.
So let's see what happens here. So it looks like that does work correctly, it seems. If I do the negative sort direction.
I don't know if negatives, can you multiply infinity by a negative number?
Sure. Infinity times -1 is negative infinity. Why not?
Well, then you have to put it in there if you want it to reverse.
I'm sorry, what are you saying?
Well, it's just returning infinity. If you want to change it to negative infinity, you can just multiply infinity times the sort direction, right?
Oh, yeah. That works.
Let's say, is that valid?
I mean, it's not much different than just returning the sort direction. Because all that matters is if it's positive or negative.
Okay.
This just makes me a little bit uncomfortable because we're only checking if a job is empty string. We're not checking if b.job is empty string, or what happens if they're both empty string. Because if they're both, we don't want to say either of them goes ahead of the other one. If they're both an empty string, we should return 0 because we're indifferent about them. It does seem in this case like it's producing the desired output, but it makes me a little bit uncomfortable because I feel like there are some cases we haven't actually specified exactly what we want, and we're just sort of relying on JavaScript to automatically accidentally do the right thing.
Well, through the logic, it wouldn't matter for the comparison, since the first object you're comparing, you're just automatically pushing to the end of the array. As long as you don't care about the order after it's at the end of the array.
I'm not so sure. I might have to look into this a little bit more. But typically, this is how I would write my sort functions. There's probably a more elegant way to do this, but I think having a bunch of if-else statements can be pretty clear if you really just have multiple conditions that you're trying to handle. So yeah, that's how you sort things in JavaScript. It's a little bit more complicated to do this in Python, to write a purely custom sort function, but the same capability does exist, where you can write a function that gets called with every pair of elements in an array, and you can return positive or negative to say which goes where. Python can work the same way. It's just a little bit more of a hassle to do that. But yeah, so that's how we sort in JavaScript. If there are any questions, we can ask them now. Otherwise, hope you enjoy your lunch.
Thank you.
Questions, anybody? No, nothing? Okay. So yeah, go on, take a full lunch, come back at 1:15, whatever. There's no more content scheduled for this afternoon, so you can work on your exercises freely. And then meet back up at 5. We'll do a stand down this afternoon. Thanks, everybody.
I appreciate it.
Thank you.